Hi everyone. This circuit is a BCD adder and subtractor. It uses two 7483 4-bit adders, some logic gates, and two 7-segment displays for the result. We have two inputs, A and B. Both are 4-bit BCD numbers, meaning they go from 0 to 9. There's also a switch called SUB that controls whether the circuit performs addition or subtraction. When SUB is off or 0, the circuit adds A and B. When SUB is on or 1, it subtracts B from A. The trick is done using XOR gates, connected to input B. When we turn on the SUB switch, the XOR gates invert. The B inputs and the circuit automatically adds 1 to make it work as a 2's complement. Subtraction. The first 7483 adder handles the main 4-bit addition or subtraction. If the output goes above 9, the logic gates automatically add 6 to fix it and keep the result valid in BCD form. Then the second 7483 takes care of the carry and displays the 10's digit. That's why we have two 7-segment displays, one for the 10's place and one for the 1's place. If the result is negative, the minus LED turns on to show that the answer is below 0. So overall, when SUB is off, it adds numbers from 0 to 9. When SUB is on, it subtracts and can show negative results with the minus indicator. This circuit shows how binary, adders and logic gates can work together to do both addition and subtraction in BCD form. When we were building this project, we soldered all the components like the switches, 7-segment displays, and LED lights onto the PCB board. We placed everything inside a box and cut the top part so the PCB board would fit perfectly and look clean. One of our struggles was fixing the low brightness of the 7-segment displays. We had to check the connections and make sure the resistors were correct. Through this project, we learn how to combine digital ICS, logic gates, and displays to make a working adder subtractor. We also gained hands-on experience in soldering, circuit design, and troubleshooting. Overall, it was a great experience because we didn't just learn the theory, but we actually built and made it work in real life. Let's share a few interesting facts about how this circuit works. A BCD stands for binary coded decimal, where each decimal digit, 0 to 9, is represented by 4 binary bits. For example, 5 is written as 0101 in BCD form. This format is commonly used in calculators and digital clocks to easily display numbers. The 7483 IC is a classic 4-bit binary adder. It's been used since the 1970s and is still a favorite for digital electronics projects today. In BCD arithmetic, when the sum of two digits exceeds 9, we add 6, 0110 to correct the output. That's how we keep the result readable as a decimal digit instead of binary. And here's a cool fact: the 2's complement subtraction method we used is the same technique used in modern computers and processors to perform subtraction.